So in this lesson, we are factoring trinomials, and a trinomial is any expression with three terms, but specifically we're going to be factoring trinomials in this form that's shown here. So where we have something x squared plus something x plus something with numbers filled in. Trinomials can be factored if they are the product of two binomials. The main keys to factoring trinomials are knowing all possible factor pairs of numbers and the ability to work with signed numbers. So whenever I've taught this before, really it's these elementary skills, elementary school skills that are make or break for factoring trinomials. So we're going to start with those two skills, even though they're pretty simple, and then we'll move on to the factoring trinomials. So for exercise 1, it says write all of the factor pairs of the following integers. So for example, with the 27, we're writing two numbers, all possible pairs of two numbers that multiply to 27. So I'm always going to start with 1 times that number. Now, remember, signed numbers or positives and negatives are important when we factor too, so I'm also going to say that -1 times -27 would work as well. So, sorry, that's a large multiplication symbol. So another pair, 2 doesn't go into 27, but 3 does. And 3 times 9 would work, and then also -3 times -9. Now, if I kept counting up, like 4 doesn't go in, 5 doesn't go in, 6 doesn't go into 27, 7 doesn't go in, 8 doesn't go in. Once I get up to 9, I know I'm done because I already have 9 as a factor on the right side. So let's look at -24. So we'll start out with 1 times -24. Since this is a negative number, we know one of our two factors has to be negative. So we could also do -1 times +24. Moving on from there, 2 does go into 24, so I'm going to do 2 times -12 and -2 times 12. The next one, 3 also goes in, so 3 times -8 and -3 times +8. And then finally 4 times -6 and -4 times 6. So 5 doesn't go in, and then we're up to 6, so we know we're done. For 80, I'm going to move up here. So we have 1 times 80, -1 times -80. And you should try this one, see if you can get all of them and kind of think through the process, and then come back and check. So this is 2 times 40, 2 does go in, -2 times -40. 3 doesn't go in to 80, 4 does. And if you're ever not sure if a number goes into another number, you can try it on your calculator. If you know some basic rules from elementary school about how to tell if 3 goes into something, if the digits add up to 3, you can use those rules as well. So 5 doesn't go in, 6 kind of maybe goes into 80. That one might be one you're not sure of. If you try in the calculator, it does not. 7 doesn't, 8 does. So we have 8 times 10 and -8 times -10. 9 doesn't, and then we're up to 10, so we know we're done. Now, once you think of all factor pairs, when we're doing the trinomials, the next step will be to choose the factor pair that adds up to, the sum of those two factors is a certain number. So I'm going to look, it says for each of the corresponding problems above, choose the factor pair that adds up to these numbers. So which of the factors pairs of 27 adds up to -12? That would be the -3 and the -9. Okay, which of the factor pairs of -24 adds up to 5? So I'm still following the same rule. I want them to add up. But when my first number, my number right here is negative, I'm actually kind of thinking about the difference between those two numbers if they were positive. So the difference between +3 and +8 is 5. Okay, so that's the one I want to use. And the ones that add up to 5, right, would be -3 plus 8. So it's -3 and 8 would be the two numbers I would choose. For the next one, 24, I know I need 2 positives here because my only choices are 2 positives or 2 negatives from 80, and 4 and 20 would work. Now, when we're factoring, it would take a really long time if we were writing down all the factor pairs each time when we do the actual problems. So you don't really write them down, but that's the skill you have to have, is the ability to kind of like go through them in your mind to find the one you need to use. Okay, so that's the skill. Now we're going to look at the problems and see how those are the two little mini skills we use when we do them. So here are our expressions, and we're going to start out with the easiest type of trinomial factoring, which is when the a value equals 1. So all of these are going to be in the form 1x squared, or just x squared, plus something x plus something. So my first one is x squared plus 2x minus 35. Now when we factor these, if we can find the factor pair that's going to fit these certain qualities, the beginning of our parentheses always start with an x, because if we think about distributing, x times x will give me the x squared, which is the first term. Now what we're looking for is numbers that add up to the b term, so add up to 2, and multiply to the c term, so multiply to negative 35. So just like above, I start with that multiplying number. I think of all my factors of 35, positives and negatives, and I go through them and I say, well, which one of those pairs would add up to positive 2? So I know negative 7 times 5 or 7 times negative 5 will work. And in this case, because the 2 is positive, I want the bigger one to be positive. So I'm going to use 7 and negative 5. So plus 7 minus 5 will work for the factoring. If we were to distribute that out, I'm going to say it, we'd get x squared minus 5x plus 7x would be the 2x, and then minus 35, right? So that would work if I did the double distributive property with these two binomials. So let's look at the next one. I see the structure. I know I'm going to start it like this. Numbers that add up to 11 and multiply to 24 are 3 and 8. Okay. And the next one, we want numbers that add up to negative 13 and multiply to positive 22. So that tells me I know my factor pairs for 22 are either both positive or both negative. I'm going to need them to be both negative to multiply to or add up to a negative 13. So 11 and 2 will work, right? So I'm going to use a negative 11 and a negative 2. And this is where that elementary math skill is really important, because some people will get these like really quick as they go through, and some people it will take a really long time to do these. So in class, we can show you some calculator tricks, but even using the calculator tricks on every single problem takes longer. So we'll try to help you and work with you, but that is, that little skill is really the make or break for the trinomials. So I'm going to go a little faster through these. So here I see another one, put the x's in front. Numbers that add to negative 5 and multiply to negative 50 are negative 10 and positive 5. On the next one, numbers that add up to negative 11 and multiply to negative 12. Sometimes these are the hardest when I have to use like the 12 and the 1 here. So don't forget about that factor pair. So this one, negative 12 and positive 1 are the factors that will work. E brings up a new situation. So on E, I have a negative x squared. And you can factor with a negative x squared, but then in the front of your parentheses, you're going to need one negative x and one positive x, and then you have to think a little bit more about what you put in the second spots. So whenever you have a negative lead coefficient, or that first term is negative, we always want to factor out a negative 1 first. So just a second, I'm in the wrong pen setting. Let's see if this works. Yeah, so I'm taking out a negative 1. And then I have x squared, that's making it negative 10x and positive 21. So all the signs switch when I factor out a negative 1. Negative 1 stays on the outside, and then I do the same thing. So what adds to negative 10 and multiplies to 21? That would be a negative 7 and a negative 3. So F is the first one where I kind of think it's a little tricky to think about all the factors of 48, because there actually are a lot. This particular pair you probably know, but maybe don't use too often. So if you're ever stuck and you can't find the factor pairs, I'm going to write this over on the side but then erase it. If you take on your calculator and type in y equals the multiplying number, that m, whatever is that c value, and divide it by x, and then you look at your table and you scroll up and down, that's going to give you all possible factor pairs of 48. So in that table, you'll see 6 times 8 and negative 6 times negative 8. And you'll also see the ones you need, which are -12 and -4. So as I said, I'm going to erase that now, just so we have room to do the problems. But this one does end up being -12 and -4 for multiplies to 48 and adds up to -16. Whenever you don't have a 1, like we've talked about in a lot of situations, you can put a 1 down, like on letter G. So factors of -72 that add up to -1, because those signs are different on those numbers, to multiply to -72, my numbers have to be pretty close together in terms of their absolute value. So 8 and 9 will work, and I'm going to use a -9 because we have -1x, so bigger number is negative, and a +8. So that's your basics of factoring trinomials when a is 1. At the bottom of this page, we're actually going to look and start to think about factoring trinomials when a is greater than 1. Now, we have a specific method we're going to use for this, but first we just want to say, like, what types of answers would make sense for this. So we're considering this trinomial, and below are 4 different guesses for what the right answer might be. So first off, this second one, I'm going to look at this first. We want to eliminate ones that don't make sense. Kind of looks good because you see how -3 times 2 multiplies to -6. But if we look at it closely, we're going to see there's a lot of problems with it. So mainly because we have 6x squared, x times x is not 6x squared. So that can't be right. That first term times the other first term has to multiply to my ax squared term. Another one that also, less obviously, but doesn't make sense is the last 2 numbers have to multiply to -6. In this one, it's -2 and -3, which would be +6. So I'm also not going to pick that one. If I check my 2 remaining problems, the first 3x times 2x in this one multiplies to 6x squared. The last 2 times -3 is -6, so that's all good. This one here, 6x squared in the front, -6 at the end. So then we have to check the middle terms. So if I multiply this one out, I get 6x squared minus 9x plus 4x minus 6. If I check those middle terms, that's not -35. Okay, so that one's no good. On this one, 6x squared minus 36x plus 1x, that looks good. Minus 6, those two, right, add up to -5 or -35, sorry. So that is the correct answer. So that's not how we factor those trinomials where a is greater than 1, but it should always make sense. It's more of a way we check to see if our answer is right at the end.